Okay, so the first thing I want to do is I want to talk about uh, the midterm exam document, because there seems to be a little bit of confusion about this. Some questions have been coming in related to this, so I wanted to clarify some things. So basically, what you're doing is you're creating your own program. You're creating some program as if you were trying to make an assignment for the other students in CSE 101 or 102. Okay, it needs to make sure that it it defines at least 6 classes, right? Just so, oh, one thing, let me go ahead and point out that when I say similar to the assignment, I don't mean this format. Like, you don't have to follow this template, okay, with the due date and the deliverables and all that. That's not what I'm looking for. What I want to know is how well you have analyzed a program to be able to come up with 6 required classes. Why do you need them? So, for example, if you are creating a program for, I don't know, a store, for example, you would need a store class. You would need a product class. You would want a customer class, right? But why do you need those things? Why do those classes need to exist in your program? Okay, you need to make sure that at least one of your classes is abstract. Okay, you will also receive bonus points if you use an interface. Okay, an interface would be in addition to the 6 required classes. As we've talked about, an interface is not a class itself. All right. What attributes should you have? Like in the store, we had website, we had name. In customer, we had name. In club customer, we had phone number. Those are all attributes. You need to tell me what attributes should I create, because imagine that I'm the student and I want to write your program. I want to write this program that you're designing. You need to tell me everything that I need to know in order to make it happen. So you need to tell me, what attributes do I need and what type is that attribute? Is it an integer? Is it a string? What methods do I need to create? What type do they return? What parameters do those methods take? Okay, you need to draw using either a tool or by hand a UML diagram showing how the different classes are related. So you'll have 6 classes in your UML diagram, right? You need to have at least 2 extends or implements type relationships. So you should know what that means. That's a requirement that you have at least 2 extends type relationships, and you need to have at least 2 association, aggregation, composition type relationships. The ones where one class uses another class, has another class inside of it. Okay, just like I do, and in fact, let me go ahead and just pull up the assignment 2 PDF so I can show you what I'm talking about here. So you need to have example code and output using your classes. So basically what you need is something like this, where, how would you use your program and what would the output be, right? So that's what this means. You need example code and output that uses your classes. It can be a screenshot. So like here, I just took a screenshot, or you could just paste it in as text. Either way works fine, but as long as we can read it, it needs to be, readable. Again, what you're doing is you are creating a description of an assignment that if I were a student, I could read your assignment and basically recreate your functionality that you expect. So when I created all of these classes, when I created the store and the customer and the product classes and all of that, when I created these things, I then used it I then used those classes by writing this code here. Okay, so you need to show me something like this that uses yours. Okay, and then finally, you must choose your own topic or system. Okay, you must come up with your own. I have no problem if you have a hard time coming up with something, for asking for help with coming up with an idea of what type of system. So if somebody were to say, "Oh, create this or that," that's okay. But if you copy code or if you copy any of the text from your description from someone else, then basically you'll receive 0 points for this exam. And when I say for this exam, I mean the 40%. I mean I don't mean the 20% that this exam represents, the half of the midterm exam OBS grade that this represents. I mean, you'll receive 0 for the 40%, which would make it quite difficult to pass this class. Okay. You also may not use either of these two. You cannot use a store because that's what we did in this class this past year. You also cannot create a bank system because that's what we did last year. Okay, so it would be too easy for you to just copy the documents that I created either this year or last year if I allowed either of those systems to be allowed as examples. Okay, so you have to come up with your own. You need to analyze it and describe it and figure out how you'll create those 6 classes with everything that goes on inside of them. So, and what I would suggest you do is for this example code and output, go ahead and create those 6 classes and run them and run some example code and see what the output is and then show me that, just like I did here. That's what I did. I created these classes, then I created these ways to use those classes, and then I showed what the output would be. Okay, I hope that clears things up and you guys are clear on that. So if there aren't any questions, I don't think there are. I didn't see anything over here. Nope. Okay. Let's see. So let's go ahead and get on to where we were going with this, which was the sets and maps. So I'll go ahead and share. Come on. Share. Sets and maps. Okay. So. Oh, also one side note, again, as I'm not doing a quote of the day, I did post another form with a question. I hope my Turkish is not too bad, so I hope it's clear. But basically, I know that none of us got to get out and go do what we normally would do on 23 Nisan last week. I would have really enjoyed going to my daughter's school and seeing the performance there, but unfortunately, we were not able to do that. So we just had to stay at home. But what would you normally do? What would you and your friends or your family do on that holiday to celebrate? All right. So let's move on. Oh, also, if you choose the other option, Bashka, if you choose that as the option of something you do, please click reply on there and tell me what you would have done. Okay. Because that way we can all kind of enjoy getting to know how different people celebrate. Okay. All right. So we're continuing our discussion. The Sets and Maps lecture is continuing our discussion on data structures to a degree. Is about different ways that we can create code to do stuff. Okay. Basically, in one way, what we talked about was that, like last semester when we created that store, remember that we created an array of things, and we had this before we had this whole object-oriented design approach. We created like these multiple arrays. Here, right? I hope you remember that when we would have like an array of prices, an array of quantities, an array of names, right? So we had a string array, a double array, an integer array, and that was really frustrating to have, these multiple different arrays that we had to constantly keep track of. So then this semester we introduced the object-oriented stuff, the classes and objects, where we could create a product, right, that has a name, that has a count, that has a price, has maybe some other attributes, right? So we could kind of keep it all together. And then that way for every product in our system, every product in our store, what did we have? We had all these attributes that kind of went along together for each product. And that was much more efficient, much more usable that way. All right. But what if we don't want to keep count in product because, you know, like take for example the Snickers bar, and I constantly come back to that because I love Snickers. They're great. I like Changa a little bit better because it's cheaper and it tastes very similar in my opinion. But that's just me. But anyway, I can buy a Snickers at Migros, right? I could buy a Snickers at A101. I could buy a Snickers at Beam. I could buy a Snickers at multiple different places, right? And so that product information, like what it is, the calories that it is, those types of things, that all can go together. But the count, the how many are in the inventory, that would need to be different, right? That would need to be different based on uh, if it was at one store or another store, right? So maybe there could be a way that we could have uh, a way to have the product be the information, the product object part be the information about the product, but then somehow, some other way, we could have uh, the count be another piece of data that goes along with it, but only for a specific store. Yeah, I don't know if that's entirely clear, but what you're going to see is what I'm describing and what I'm adding. But basically, the next assignment, the final assignment, is going to be is to use a map. Okay, to use a map to be able to have a product that's a key, and then how many of that product a store has as the value for that key. Okay, and we will talk about that. But first, we're going to talk about sets. Okay, so before we get to maps, we need to talk about sets. Okay, because it's in order. All right. So basically, the idea here, the example here, is we have a student roll call, like students in a class. So you are in this class, and we want to see who is in the class, right? And it's a roll call as a list, but we wanted to write a program that checks whether a person is in the list. Okay. Now you could use a list to store the names, right? The problem is that, or to store the student ID numbers, or whatever. All right. What we could do is we could store it into a linked list or into an array list. All right. And then we could go through one by one in the list and see, does it have this value? Does it have this value? Is this in here? Is it equal to that? Is it equal to that? The problem with doing it this way is it's not very efficient, right? We would like to have a way to just check and see if the value is in there. And the reason why it says a set is a more efficient data structure is because a set, right, is a collection, is a type of collection. We talked about this before, but unlike a list, a set does not allow for duplicates. So what this means is that if you are in the set, if you're in this class, so if I were to pull up, let's go ahead and pull it up here. All right, 1 second. Okay, so here we have 13 people in the set of students that are currently attending this lecture. All right, so here we have these students are currently in this lecture. Right? So if we were to say, okay, well, what about these others? There's some people I could choose to invite, some of whom are not logged on, right? Right? These people would be not in the set of students that are in this lecture. Now, what I'm getting at is I'll just pick one, Ismail, okay? If Ismail is in this lecture, right, then he's only in here once. Like there's not more than one Ismail Bosch, right? There's only one. It doesn't allow me to add Ismail again and again and again, right? Because he can only be here one time. All right, that's what a set is. So we don't have to worry about duplicates, because remember the thing that we came across was that with a list, with an array, with those types of data structures, we allowed duplicates. And the reason why we allow duplicates is because they may need to be in there more than once. Okay, but a set a set, if you understand set theory, the idea is it's not allowing duplicates. It's basically just a question mark of, is the thing in the set? Is the thing not in the set? Okay. All right. So question. The other thing is that a set, because it just represents a collection of items that is whether it's either in there or not. It's also, we don't order it. There is a sorted set, and a navigable set would be part of that. But generally, a set on its own is not orderable. It doesn't matter. It doesn't have an order to it like a list does. So in a sense, even though we might refer to something as a shopping list, right, as things to get from the grocery store, probably more accurate to call it a shopping set, because if you put bananas in your shopping set, right, you don't have to put it in there more than once. Bananas are either in the set or not. And if you're my oldest son, you don't want any fruit at all, so bananas would never be in his set. But but the idea is that it's either in there or not, and it doesn't matter what the order is, right? Now, maybe some people might say, well, wait a second, a list is a better data structure for a shopping list, because if I'm smart, I will make sure to put certain items in the list first and then some later. And the reason why you would do that is because based on location in the store, right? You don't want to have to keep going from one end of the store to the other, one end to the other, one end back and forth, because you want to be able to just shop one time and just kind of make one pass through the store would be ideal. So, all right. So I hope that kind of clears up some of the, maybe if you had any questions about the differences between sets and lists. Okay, and then as we move on. All right. So we're going to talk about what the set is, right? So basically, the only thing is that a set extends the collection. It's just a collection, but it does not introduce any new methods. But the one thing that it says is that you cannot have duplicate elements. So if you try to add something to a set that's already in the set, it doesn't change the set. Okay. So there must make sure that there's no duplicate elements, right? In other words, there is no two elements, E1 and E2, that can be in the set such that E1 equals E2 is true. Now, that does not mean that E1 dot compare to E2 cannot return 0. Remember, equals and compare to are different things. Equals is a Boolean method that tells us whether or not two things are the same, are equal. Not that they necessarily point to the same value. So, for example, two strings might be equal, right? That doesn't mean that they point to the same thing, the same object in memory, right? The main reason why I want to get to this, main reason why I want to focus on this is because when we talked about geometric objects, one of the things we talked about was defining that compare to method, where we said that the way that we determined what greater than, less than, or effectively equal to was based on the area. That's what we kind of chose to use as our test, right? Was the area of the two objects, which meant that you could have two rectangles that had the same area, but were not the same, right? So like a 1x20 rectangle would have the same area as a 4x5 rectangle, right? Or you might have a rectangle if one of its sides was some multiple of pi and the other side was another multiple of pi, that you could end up with, or no, if some side was multiple of pi, you could end up with a rectangle and a circle having the same area, and so they would be their compare to method would return 0, right? But that does not mean that those two things are the same thing. That's different, right? So what you would say is, if you had what you could do is you could have a set of geometric objects where a rectangle 1x20 can be in the set. A rectangle 4 by 5 can be in the set. But then what you would do is if you tried to add another rectangle that's also 4 by 5, then this should reject that insert, right? You shouldn't have 2 rectangles that are 4 by 5 in the set. You should only be able to have 1. Okay. Hope that's clear. I'll try to come up with some examples that we can look at. Okay. All right. So this is some of the hierarchy of the set interface of how we can create sets. Okay. You have a tree set, a hash set. We'll look at some examples. All right. And my plan for today is to spend today looking at sets and tomorrow looking at maps. So that's what I'll plan to do. Okay. All right. Let's get past some of this. This is just basically kind of information for how Java implements the set interface. I will look at this example, the test hash set method. But one useful tool that Java gives us is to be able to iterate over the objects in a set. Okay, so basically it's like a special for loop. We'll call this the for each loop. All right. We had this with arrays. All right, we talked about this with arrays, but we can do this with any type of set, any type of collection. All right, and so because the collection is iteratable, so we iterate over each value in the set. Now, one of the things about a set is that because its very nature is not ordered, it's not an ordered list, it's not an array or an array list. And so when we do this for each loop, we don't know the order that this is going to come out in. It's just going to say, give me an item in the set, put it into element, do something with element. Give me the next item in the set, do the same thing. Give me the next item in the set. Do this until I've looked at every element in the set, right? No duplicates, but do this for every element in the set, for everything I have in the set, right? Until I'm done, until I've done every element in the set, right? But before we run this code, we do not know the order that this is going to come out in, okay? Which for a lot of things is not that important, right? Order does not really matter a whole lot. For example, if I were to say I wanted to print out a list of all the students that came to lecture today. Okay, I want to print out a listing. All right. Does it really matter what order you come in? Does it really matter what order I print you in? And generally, no. Right? It may be for me, from my eyes, I would like to see you in alphabetical order or by student number order or something like that. But generally, I just want you to print it out, right? Or if I wanted to, I won't do this because many of our students, the reason why they can't attend lectures is because of lack of consistent internet at their house. But if I wanted to say, I want to give bonus points to anybody that showed up to lecture today. Right? Could I do that using a set? Yeah. Does it matter the order? Does we go back over here? Just because I guess it has you in alphabetical order here. Just because Hassan happens to show up before Camille over here, right? Does that mean that Hassan should get more or fewer points than Camille? And neither one of you needs to answer, right? Because the truth is, if I were doing this, then the answer would be no. I don't need to give more points to somebody just because they happen to show up earlier in the list, right? So I could use a set, right, to say add points to each student that's in the set. Okay, so that would be an example of how we could iterate over each value, each thing in the set and the order doesn't really matter. Okay. All right. So there's another example we may take a look at. All right, tree set, we may take a look at that because this is a sorted set. So the example where you may want to have a sorted order, right, would be with the tree set. My guess is that the tree set is done using a binary search tree, which is another data structure that you will learn about in your data structures class. Okay, right. The thing about with anything sorted is you have to have, it has to be comparable. So it either has to implement the comparable interface, right? Or it has to have a comparator defined. Yeah. All right. The compare to method has to be defined. Okay. Right. So there's the tree set. I won't look at that example today. If I remember correctly, there's something. That's a map. I think this is a set. Okay, we'll look at that one. All right. Pulled the test tree set. Because if I remember correctly, yeah, okay, yeah, I pulled this up and I wasn't gonna look at it because it uses a lot of. Oh, actually, it's a test tree set with comparator that I don't want to look at today. Because yeah, it uses a lot of this other stuff from other places. So I'll deal with that later. So maybe we will go ahead and look at this. The test tree set. Okay. All right. So then you can also with a comparator. Okay. I do want to look at set list performance. I have it here. Yep. Yeah, I do want to look at this because we're going to see something cool with this that I want to show you today. Okay. And I think, and then the count keywords, we'll look at that as well. Okay. So that is the slides on the set stuff. I want to look at these other examples and we will finish up here in just a moment. So I do want to go ahead and look at the examples. And at any point, I get a notification over here. If anybody writes a question during the lecture. So if you have a question, go ahead and write that. And so that I can go ahead and see it and we can answer it if you have any questions in the middle of the lecture, okay? All right. So let's go through and just look at some of these, all right? So, okay. So we're gonna create a set, all right? And let's take a look at what this looks like as we step through, okay? So we're gonna create a new hash set. I wanna see what it looks like, okay? So let's see what it looks like. We're gonna add, so it's a string, it's a hash set, it's a set of strings, okay? Now, the way that this looks is, so you see, okay, so I got Paris in here, okay? London is gonna get added to my set, and it gets added right here. Now, it's a little bit beyond the scope of this class, of this particular of CSE 102 for me to go into too much detail about this. But the reason why this is called a hash set is basically every time it goes to add something, whatever this object is, in this case strings, whenever it goes to add this to a set, the first thing to a hash set is it based on the string, based on this object, it creates a hash value. Now it creates a hash value by default between 0 and 15. It's one of 16 values between 0 and 15. It's all based on binary, based on 4 bits of information. When you get to your digital logic class, you'll understand a lot more about why binary is used. Right now, you probably have a basic understanding of that, but you'll understand a lot more once you get to your digital logic class. But basically, a hash value is determined. So Paris got a hash value of 14, so it was put here. Right? London got a hash value of 8, so it was pushed here. Okay. Beijing, where did you get put? Beijing got a hash value, sorry, New York. New York got a hash value of 1, so it got put here. Beijing got 0. San Francisco, I think, is going to be also 0. Okay, so for whatever reason, whatever the hashing algorithm is that our executor uses, Beijing and San Francisco gets the same hash value. Okay, and this is going to be important for how we're going to go through the set. It's not important for you as a user or for you as a programmer to understand what the different values of hashes are. Okay, So, question. New York is going to get put into the set, right? Okay. Somebody say no. Because what's going to happen is New York already exists in the set. Right? So it didn't get added anywhere because it was already here. Okay. So I'm going to print the set. What's going to happen? It prints it out in kind of an array type of format. Okay. Now, what was the order? Notice this order is not the same as the order we put it in, which you would expect because this is a set. The order doesn't matter. So, but if you'll notice, the order it did come out in was based on hash value. So Beijing and San Francisco came first, New York came next, then London, then Paris. Okay. So now when we go looping through, when we go through this for each loop, printing out the values in our set, first object is going to be Beijing. Second object is going to be San Francisco. Basically, it's the same order as this, or it's the same pass-through order as this. Okay. Yeah. We can also use this for each method. Okay. This is a new thing that we're teaching you also. Is inside of the set we have a for each method, and so for each E in the set, I want to print E to lowercase. Okay. So basically, what's going to happen is you can put one line of code over here, right? Assign it to a variable value. Basically, this would be kind of like this, right? But in a more concise one-line format. Okay. Notice it's going to do the same thing. This time, because this is seen as one line of code, it gets like this. I just step over it and it's done. Okay. All right. So let's see a couple of different changes, because one thing you might be thinking is, well, yeah, but strings are I can't remember that special word that we gave, where strings are stored kind of. So if you give me the same string like this twice, it's going to just see it as the same object, right? The same exact object, but they don't necessarily mean two equals, right? Okay, so let's look at it this way. Let's see. Remember that this actually does create a new string. This right here, this object will not point to the same as this. So let's see what happens. Will our program, let's see. Will our program see this New York as the same as this New York and not put it in there twice? Let's see. Okay, so Paris, same place as before. London was what, 8? Yep, there it is. New York is there, Beijing is there, San Francisco is there, New York. Nope, only shows up the one time. And the reason why is because even though these are two different objects, they have the dot equals method returns true because these represent the same thing. Okay. So let's keep it. Okay. Because one other thing I want to change, and I want to see how this works. I'm going to also work with New York again. This time, we're going to do this. Okay. And let's see what happens. Paris, good. London, good. New York, good. Beijing, good. San Francisco, good. Now what's going to happen? What? It's there. See, because this and this are different, therefore they are not the same, right? And another reminder that just because you use the same alphabetical letter, if it's not the same ASCII value, it's not the same. Okay. All right. So that's a way that we could use sets. I'll run this out to the end. And we'll end it. Okay. Don't want to save this. Okay. So that's how a set would be used. Okay. I'm going to return this back to the way it was before. Okay. I encourage you to look at this and just have some fun with it. Okay. Tree set. So just some different methods of that. What I want to do is I want to see how the set thing gets implemented here. Okay, so it's going to look probably pretty similar. So London gets still there at 8. So I guess it actually is very similar. Okay, so I guess it actually is the same type of data structure. I was expecting a binary search tree. Okay, so, but it's still going to do it sorted somehow. So I'm not really sure, what the, oh, I see why. I have the wrong one up here. Let me push this away. Tree set is what I want. Well, yeah, there it is. It is like a tree structure. So this is what we would call a binary search tree, okay? So basically, this is a root node that then follows branches down to the leaves of the tree, okay? Again, I want to introduce you to this view, to what this looks like, because even though this is well beyond what what this class is all about, when you get to your data structures class and when you get to your algorithms classes, I do want you to at least have an understanding of what this looked like when you get there. Okay. Cool thing about this is we can see what the first value in a sorted tree set is. We can see what the last value is. San Francisco. All right. And there's all kinds of cool algorithms for how that gets determined. Okay. So it's at New York. So it's basically what does this do? What is the set to the left of it? And then tail set is what's everything to the right of it. Okay, so after New York, you're going to see San Francisco and Paris show up. And it's actually going to come up. Oh, and it includes the root node. So this includes the root node. Okay. All right, so basically this, and then this other stuff about polling has to do with taking values out. All right. And take values out. It's kind of like in the stack, the pop or the queue, can't remember what Java calls it. It's not DQ, it's a poll, I think, poll. And so it's basically polling the first value in the set, polling the last value in the set, and what's in the new tree set there. Okay, so that's some cool ways to use the tree set to be able to have an ordered set. All right, so that's basically how sets would get used. All right, so let's take a look at a couple more things, and then we'll call it a day. One is I want you to see. I'll go with the count keywords first. So the idea here is if we wanted to look at a Java file, a Java source code file, and we wanted to count, all we want to do in this example is count the number of keywords. We're not necessarily seeing how many times different keywords appear, abstract, assert, Boolean. We're not seeing how many times each of those appears. We just want to see how many times any of these appears. So we could go through, one by one. Okay, so the word, let's see, import is a Java keyword. So 1, 2, 3, 4. We could do that, right? But that's not what our job is. Our job is to find the number of is to do this through program writing, so that it can be done faster, especially on large Java files, because I'm imagining none of you, I definitely don't want to do this, none of you want to go through a Java file line by line, word by word, counting how many times different keywords appear. Even though a lot of our IDEs give us this this cool thing where it changes the color of our keywords, so it makes them easier to count, but still none of us want to go one by one and count this, right? All right, so basically we're going to enter this. I won't go through in detail because this is basically 101 stuff over here for you guys. So it's basically the idea of, getting a string from a user and finding a file name with that name. Okay. There is a method called count keywords. So now what we can do is we could create a string array that has all of the Java keywords in it. So this is all of the Java keywords, right? Including true, false, and null added to the end. All right. Okay. And then we create a set from that. Notice that, again, if a word appears, it's only going to appear once. Now, in the array, we could have had this show up twice. We could have had something like this. No problem, right? But in a set, what's going to happen is this additional throw is going to be thrown out, is going to be removed because it's a duplicate. We're not going to be allowed to have duplicates. Okay. All right. So we create a set from the array, right? An array is a list, and basically we're going to create a set from that array. Okay. And then we're going to go into our file. We're going to create a scanner to scan the file. And as long as there's a next value, as long as there's something else to read in the file, we haven't reached the end of the file yet, we're going to get the next word, whatever that is. Okay. And the way that Java does next, right, does words is what? It just reads until a white space character, right? It just reads away until a white space character comes in, and it checks if that keyword is, and so sorry, it just reads until a white space character comes, turns that into a string, puts that into this variable word. And then we just check, does the set contain that? If so, add one to count. If not, don't add one to count. All right. So I'm going to do a couple things. One is let's just use this. Let's use count keywords. Let's use count keywords as our source file. So let's go through and count them real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That looks like it. Okay. So we should get a value of 22, right? Let's run it. And let's say count keywords .java. Okay. Now there's no problem with this. We can use it's this file as the input to this file, as the input to this code. Because remember, what Java is doing is it's not running keywords.java right now. It's running count keywords.class. Right, if we look over here, you see it's running this. This is just a text file. So I'm just basically passing this text file to this program. Okay, I can do that. All right, so if I hit enter, what do we say, 22? Wait a second. 24? That doesn't look right. Why is it 24? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Huh. Well, wait a second. Okay, let's try something. Maybe let's add something, because that doesn't seem that seems to be a logical error, doesn't it? So let's, in addition to adding count, let's go ahead and print out what the word is. Okay. All right. So let's see what the words are that it sees. Okay. So now let's go through. Okay. Import. That looks right. Public class, public static void. So far so good. Throws. New, if, else, public static int, throws. So we're here, good. False. No, I don't see false or null. Where is that? Do you see it? Those of you who are paying attention? I see it right here. All right, so there is a slight possible logical error here, right? Why? Because what it's doing is, yeah, thank you. Yeah, good job, Marat. Let me see, where are you? Good job, Marat. Good call. So the problem is that when it reads in word by word, it doesn't know that this is a comment. It just knows that it read in this string of characters. It read in this string of characters. It finally got to here. It read in this as a word. It read in this as a word. And this, and this, and this, and this, and so forth, right? So why didn't it catch true? Okay, and the reason it didn't catch true, why it skipped over true, is because true had a comma on it. Remember, when we read in this has next, when we read in the word using next, it reads from this white space character all the way through to the next white space character, and then gets everything before that as the word. Okay, so true didn't come in because it had a comma on it. False, however, was just by itself. Null was by itself. So maybe for those of you who know about the Oxford comma debate, this might be a reason to use it, I guess. But the thing I'm trying to get at here is this could be a logical error if what you really want to know is how many Java keywords are used in actual executable code, actual lines of code. Okay, so anyway, yeah, so that's why 24. The 22 we counted plus these two here. Okay, this would also be something that we could do, for use in checking complexity of a code or something like that. But what I encourage you to think about is, how might I be able to not let this false and this null show up in my list, show up in my reading here? Maybe have some way to test if a line is part of a comment. Okay? So I leave that for an at-home exercise for you to think about. Okay, is how you might do that, how you might take this line and say, I don't want to include you in my results. Okay. One final thing we'll talk about today is the different performances of how these different things work. So what we want to do is we're going to create a list, an array list. We're going to add the numbers from 1 to n, whatever n is. Okay, in this case, it's going to be 50,000. Then we're going to shuffle the list, right? Okay, and we're going to create a hash set from it, and we're going to find how long it takes to find something in the set, and then versus how much it takes to remove an element from the set. Okay, then we're going to also look at the same thing for a linked hash set. How quick is it to find something, to find if something is in this, different values are in the set, in a tree set, and then we're going to continue it as an array list. and a linked list. And this way we can see how good or bad some of these things are at some of the different functionality that we would want to do. Okay, so the get test time is it's going to try to find if a certain value exists inside of the set, right? And it's going to say, for this, basically, how long did it take to find n values in the set? Okay, and then get remove is going to say how long did it take to remove all of the elements from the set. Okay, because remember, what's in the set, collection. What's in the collection is the values from 0 to n, right? That's what we started with. That's what we created. Okay? And so what we're going to do is then we shuffle it, so we basically randomize it, and we're going to get the total time for finding n random values in the collection. Then we're going to find how long does it take to remove all n values, knowing that they're randomized, they're shuffled. Okay, so think about, before we do this, which one do you think is going to be fastest for finding a value? Which one do you think is going to be slowest for finding a value? Which one do you think is going to be fastest for removing all the values? Which one do you think is going to be fastest or slowest for, slowest for removing all the values? Let's take a look. Let's have some fun. It's still not done, it's just taking a while. Because now we're into the array list. Okay, so finding values and removing them pretty fast with our two sets thing, with our linked set, right, for our tree set, all right, as we would expect, right? So because finding means we don't have to necessarily go through all of them, we just have to find the hash value, look in that, because remember the way that the hash set works is it hashes it to a specific value from 0 to 15, and then it puts it into that, and then it basically kind of creates this list off of that hash value. So basically, I don't have to search the whole set for a value. I only have to search through that one sub portion of the set that is that hash value, that 0 to 15 value. So hash set is going to be really fast. A linked hash set is going to be even faster. And I encourage you to look at what a linked hash set looks like graphically, what it looks like visually. And then a tree set is going to be pretty fast too, although it won't be as fast because unlike the hash set, the tree set, I still probably have to search through from the start half of the values in my tree set. Okay, here I only have to search through approximately 1/16 on average of the values in my tree set. Here I have to search to about half the values in the tree set. Okay, array list and your linked list is going to be super slow for finding and removing values, right? I mean, okay, yes, 2,000 milliseconds, 2 seconds doesn't sound slow to you, but again, as we've talked about plenty of times, let me just go ahead and pull this up. If I were to pull up Google and I were to say Java hash set, okay, right? Google says I found this many results in less than half a second, right? So Google likes to be fast, right? 2 seconds to find out if a value is in the set, that's a long time, right? And that's just searching, just searching a collection of integers. That's not searching the web, right? And so 2 seconds, long time, right? Same thing with linked list. Again, the whole reason is for an array list, I might have to search through the entire array list to find out if something is in that array list or not. And for a linked list, same thing. I'm going to have to parse through. I'm going to have to go through value by value to find where this value is in the linked list. Okay. Again, let me tell you that one thing that's just coming to mind that's beyond this class specifically, but I do want you to be prepared for it. I want you to have heard it before you even get there. When you get to your algorithms class, you're going to talk about why these things are the way they are, why a hash set works faster in certain situations, what types of data structures might work slower, what types of ways we can help make our algorithms run faster and more efficiently. Okay, but just know that for both the linked list and the array list, in order to search for something, in either of these lists, I might have to look through every value there. Might have to look through every value in the array list, right? But for a hash set, I only have to look through about a 1/16 of them for any given value. Okay, so I hope that was insightful to you. I hope you kind of understand why these things are the way they are. Again, we talked about the midterm assignment, so I hope you're clear on that. And if there aren't any questions or comments, if there aren't any questions or comments, then we'll go ahead and call this an end for this lecture. And we will, like I said, we will finish up with maps tomorrow. And I look forward to having that discussion with you as well. Again, please, just for fun, go ahead and comment. Go ahead and fill out that form. The what do you do for the Chojik Bayram? And because I think it'll be interesting to see how some of you enjoy celebrating holidays here. All right. Thank you guys for joining us, and I will see you tomorrow morning.